Hey guys, so this is the video from section 3.3. Section 3.3, it's about graphs of basic function and piecewise function. So mostly in this sections, you just need to recognize the graph of major functions. Okay. So objectives, sketching the graph of basic functions, analyze piecewise defined functions, solving application of piecewise defined functions. So 3 objectives only. So first, what you guys see, you see the graph of the constant function. So graph of the constant function that f of x equal b. So here, the graph of the constant function. So this is the constant function. Okay. So the equation of this graph, it's f of x equal b. So for example, f of x equal 4. So you're going to have a horizontal line. Constant function that's going to be horizontal line. F of x equal 4 is the same as y equal 4. Okay. So it's a linear function with the slope equals 0. So just remember that any constant function, horizontal function, always have a slope equals 0. Okay. And of course, it's a linear function. Next function which we need to remember is identity function. That's the straight line which goes through the origin. You may think about diagonal line. So the identity function has the equation f of x equal x. So for identity function, you have a points on the graph like 1, 1, 2, 2. So where x and y values are the same. That's why we call it identity function. So that's when x and y values are the same. And of course, this is a linear function. And for identity function, the slope is equal 1. Slope is always equal 1. Okay. So identity function. Next graph which we need to know, it's a square function. F of x is equal x squared. Okay. So this is the quadratic function. We will talk more later about quadratic function, but we have a vertex here at the origin. And this function has y-axis symmetry, which means it's symmetric with respect to the y-axis. It's an even function. So square function, definitely it's an even function. And you guys see the basic graphs. Of course, we have transformation of those graphs. Next one, cube function. F of x is equal x to the third power. Cube function is add function, which means origin symmetry. This one was even function. Had that y-axis symmetry. Okay. And also here, when we describe identity function, we have, this is also add function. This is add function, which means has that origin symmetry. And the previous one, constant line, this is even function. We have that y-axis symmetry over there. Okay, so let's go back to our cubic function, cube function, which is the add function. Again, if you have a point on the graph 1, 1, you're also going to have a point on the graph with opposite x, which is -1, and opposite y, which is -1. Okay, so this is, and cube function, it's increasing function in entire domain. It's increasing function. From negative infinity to infinity. So it's increasing function. Here, let's just describe more. This one, the quadratic function, it's decreasing function and increasing function. So function decrease, this function decrease for x values from the interval from negative infinity to 0, and this function increase here for the x values from 0 to positive infinity. Okay, I will go back here. So when we have identity function, slope is equal 1, so slope is positive, that means this function will be increasing. Function increase in entire domain. Function is increasing from negative infinity to infinity, which means for all real numbers. And our constant functions, constant, that means it's just constant. We see that horizontal line. Okay. So next function, we talk about cube function, absolute value function. Absolute value function. Absolute value function is definitely even function. We see that y-axis symmetry, and this function also it's decreasing. When x are getting larger, y value getting smaller. So this function decrease, similar like a quadratic function from negative infinity to 0, and this function increase right here when x are getting larger, y getting larger. So increase from 0 to positive infinity. So this is absolute value function. Like you see, this function only have the y values from 0 to positive infinity, because we know the absolute value of negative number will become positive. Next one is the square root function. Okay, square root function, it's neither, not even, not add, and it's increasing. This function is increasing. It's increasing from 0 to positive infinity. Okay. So next function, cube root function, cube root of x, cube root function, cube root of x. Okay, this function is also increasing, and this function is also add. So it's add function, okay, has that origin symmetry, and it's increasing. Function increase in entire domain, which means from negative infinity to infinity. So this is cube root function. Reciprocal function, which means f of x is equal reciprocal of x, 1 over x, very specific function. This function is add. We have that origin symmetry. So like you see, this point and this point are matching. This point and this point will matching. So this is definitely add function. We'll just leave it like that for now. Okay. Reciprocal function, we need to remember the shape of the graph. Now, domain of this function is the set of all real numbers, because this function exists for any x values except 0. And the range of this function will be the set of all real numbers except 0. So this function has vertical asymptote at x equals 0 and horizontal asymptote at y equals 0. So I think I will write this down for you guys. Here the domain domain is from negative infinity to 0, union 0 to positive infinity, and range is the same. It's from negative infinity to 0, union from 0 to infinity. So x value cannot be equal 0 and y value cannot be equal 0. Reciprocal function. Greatest integer function, for some reason it copied wrong. The greatest integer function looks like that. Some textbook using like double bracket. It depends of the textbook. Again, don't get confused with absolute value function. I'll just erase that. So greatest integer function, that means that x can be any real number. The output has to be the integer. The output must be integer. Okay, the greatest integer function. Let me give you the example. F of x equal the greatest integer function 2x minus 1. Okay. Oh, you know what? Let's just keep that basic one. Let's keep that x. So how are they graphing this function? So let's create a table of values. We have x. To get y, we're going to take the greatest integer, and then we need points x comma y. So the output y value always will be integer. So when x is equal negative 5, the y value will be also negative 5 because negative 5 is integer. So I replace x with negative 5. So we have point negative 5 comma negative 5. Now, when x will be equal negative 4.5, the y value has to be output. So we have to think about the greatest integer of which is close to negative 4.5. So think about point negative 4.5. That's between two integers, negative 5 and negative 4. Okay. So what we're going to select, so the output has to be of the greatest integer function has to be the integer which is less than negative 4.5. So you're always going to select the integer which is on the left side. So it will be negative 5. So we'll have a point negative 4.5 comma negative 5. So the output must be integer. And let me give more information that the output, which means the y value, must be integer which is equal to x, or when the x is not the integer, or less than x. Okay. And one more example. Let's say when x is equal 1, since 1 is integer, so output y will be also integer 1. So we have 0.1 comma 1. But when the x is the integer 1.5, I'm sorry, the number 1.5, so the output has to be integer. So we have to select the integer which is smaller than 1.5. So we'll select 1. So we'll have a 0.1.5 comma 1. So the greatest integer function, like you guys see, the y values only can be integers. Okay. So if our input is integer, the y value will be the same integer. If the input is decimals or any number but not integer, then for the output we need to select the closest integer which is smaller than negative than our given input. So in this example, the closest integer which is smaller than negative 4.5, it's negative 5. when x was equal 1.5, we have to select for output the integer which is smaller than 1.5, which will be 1. So always select that integer which is on the left side, the smaller integer. And piecewise defined function, that's the function where we're putting different pieces together and we're creating brand new function. How are you going to know that you have piecewise defined function? First of all, you're going to see that parentheses, okay? And here they're telling you the absolute value of x function. It's been creating from two different pieces. So this is the graph of absolute value of x function. And to create the absolute value of x function, we have the graph of the straight line, the slopes, the graph goes down, the slopes, it's -1. So this is the function x, y equal -x, right here. And here we're giving the condition. So this function, y equal -x, only works for the domain for x is from -infinity up to 0. So for x is less than 0. And then the second piece of absolute value function is this one, y equal x. And here we have to give the condition. The red function works only for x is greater than 0. So we're putting two different functions together and that build brand new function. That's why we call it the piecewise defined function. So functions that are defined by a rule that has more than one piece. And example 1. In example 1, we need to sketch the graph of piecewise defined function. We have two pieces here. We have quadratic function. And this quadratic function only will work for x is less than 1. And then we have linear function. So I'm going to graph the quadratic function in yellow. So this one will graph in yellow. So let's work with that quadratic function first. So graph f of x equal x squared only for x is less than 1. So I will just create the table of values. So for our domain, I only can select x is less than 1. So I will select x equal -2. So y will be equal -2 to a second power, which is 4. So we have a point -2 comma 4. And I will select -1. So y will be equal -1 to a second power, which is 1. So we have a point -1 comma 1. And I only can select x is less than 1, so I can select also 0. When x is equal 0, y is equal 0 to a second power, which is 0. So we have a graph 0, comma 0. I will graph this soon, okay? Next, I'm going to I'll graph that soon. Next, I'm going to start creating table of values of the second piece, which is linear function. I will graph that in green. So then we're going to graph f of x equal 1 minus x. And we're only going to graph it that for x is greater equal 1. So let's create the table of values. So y is equal 1 minus x, and we have a point. Since it's a linear function, so we need 3 points only to graph it. So the first x which I can select can be 1. So y will be equal 1 minus 1, which is 0. So we have a point 1 comma 0. And Then I'm going to select any x greater or equal to 1. So let's select x equal 2. So we have y equal 1 minus 2, which is negative 1. We have 0.2 comma negative 1. And one more. Let's pick x equal 3. So y will be equal 1 minus 3. And this is negative 2. So 3 comma negative 2. Okay. So we're going to graph. Okay, the second piece is going to be graph in green. The first piece is going to be graph in yellow. So let me go to the next page. X, Y. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1. Negative 2, 3, 4, 5. And so on. Okay, so first graph will be in yellow. So that's quadratic function. We have point negative 2 comma 4, negative 1 comma 1, 0 comma 0. Negative 2 comma 4, negative 2 comma 4, it was 0 comma 0, and negative 1 comma 1. Okay. Okay. So this is the part of the quadratic function. And like you see that quadratic function only works for x is less than 1. So here I have to keep open circle because x equals 0, it's not, excuse me. X is less than 1, okay. Okay. So now let me just select one extra point here. We know that when x is equal 1, we're going to have a hole. It's not part of the graph, but when x is equal 1, y value will be equal 1 to a second power, which is 1. And we have a point 1 comma 1. It's not part of the graph, that's where we're going to have a hole. So right here, oops, it's going to be a hole. Okay. So that's the first piece. That's our quadratic function, but we only graph this quadratic function for x is less than 1. Now, next one, the linear function, we select 3 points and we're graphing that linear function only for x is greater or equal 1. So we have point 1 comma 0 right here. Then we have a point 2 comma negative 1 right here. And then we have a point 3 comma negative 2. So 3 comma negative 2 right here. So the graph will be the straight line. Okay. So it will be keep going down because for x's we can select any x greater or equal 1. So this is the graph of piecewise defined function. We have a quadratic and then a linear function. Okay. And the next part, find a rule that describes the following piecewise function. So here they want you to find the equations. Okay, for this piecewise defined function. So here, this piecewise defined function has 3 different functions. This is function 1. This is function 2. And this is function 3. So function 1 and 3, I can see that they are straight lines. Function 2, it's the constant line, which was it's a horizontal line. So first, find the equation. for function 1. So to find this equation, this is linear function. We have a linear function. So to find that equation, we have to find the slope and y-intercept. Okay. So to find the slope, right now I'm not checking the restrictions. I just want to get the equation of this function. Here you see a segment, but technically this function will be keep going that way. Okay. And then I will restrict the domain. Okay. So slope, we're going to find the slope by finding using the slope formula. y2 minus y1 divided by x2 minus x1. So the first point here, point A, don't worry that it's a whole. I'm just trying to get the equation of entire straight line. Later we'll restrict the domain. So point A has coordinates -3, 3. And point B has coordinates 2, 0. So here this is our x1, y1, x2, y2. So the slope will be equal y2. So we have 0 minus 3 divided by x2 minus x1, 2 minus -3. So we have -3 over 5. So this is the slope. And now to find the y-intercept, so we have y, it's equal -3 over 5x plus b. And to find the y-intercepts, couple ways we can do it. We can just read that y-intercept from the graph. We know slope it's -3 over 5, so that means down 3 and going 5 to the right. So to locate that y-intercept, from this point I will go down 3, 1, 2, 3, and 5 to the right, 1, 2, 3, 4, 5. Okay. Did I do that correctly? 3, 3. And this point right here is -2. I'm sorry. Okay. I noticed that something was wrong. It was -2, 0. So y2 minus y1, so we have 0 minus 3 divided by x2 minus x1, so -2 minus -3. So we have -3 divided by -2 plus 3, which is -3 divided by 1. That's our slope. So we have rise over run. So to find the y-intercept, so our function will be -3x plus b, which is the y-intercept, and I'm going to use the slope. I will go 3 units down and 1 to the right. So 1 from this point, I'm going 3 units down, 1, 2, 3, 1 to the right, 3 units down, 1, 2, 3, 1 to the right. So here it's going to be the y-intercept at point. So this is the y-intercept at point 6, -6. Or you could find that y-intercept by plugging in the points. So this is the equation of line 1. Y it's equal -3x minus 6. And this function only works for x's right here. So we're talking about working only for x's between -3 and -2. Okay, so we have to restrict that domain. Okay, next, so that was the equation of function 1. This is this function 1. Okay, now next we're going to find the equation of function 2. So I'm talking about this equation of this function. So this is constant function. So that means f of x equal b, and b represents the y-intercept, which is 2. So this function will be f of x equal to the horizontal line. And now we have to restrict the domain. This function works only for x's between -2 to 1. Including -2 and including 1. So this is the equation of function 2. And lastly, we're going to find the equation of function 3. So like you see, this is a linear function. So I will do the same thing. I'm going to find the slope, and then again, I will try to figure out what is the y-intercept, because technically the linear function will never stop, but we're giving the restriction for this linear function. So next we're going to find the equation of function 3. Again, here we restrict the domain, but be aware that this function, it's a straight line, which will be keep going up also and keep going down. So last part, find the equation for function 3. This is linear function. Y equal mx plus b. And our linear function will have a restricted domain, will only work for x from 1 going all the way to positive infinity. So here it works only for x is greater than 1. Okay, so linear function, we're going to find the slope using slope formula. So select any 2 points which belongs to our equation of function 3. You can select point 2 comma 0. So we have a point 2 comma 0, and the second point which you can select point 3 comma -1. Okay, so x1, y1, x2, y2, slope is equal y2 minus y1, so -1 minus 0 divided by x2, which is 3 minus x1, 3 minus 2. So we have -1 divided by 3. This is the slope. So to find the y-intercept, I will go down 1 unit, 3 to the right. Or you can do the opposite. Go up 1 unit and 3 to the left. So we know the slope. I need the y-intercept. It doesn't make sense to go down 1 unit 3 to the right to find the y-intercept. I see that y-intercept will be somewhere here. So I will do the opposite. The slope is -1 over 3. So I will go up 1 unit and 3 to the left. From this point, I'm going up 1 unit. Or from this point, I'm going up 1 unit, 3 to the left. 1, 2, 3. Something's wrong. Excuse me. It was a silly mistake. -1 over 1. Which is the slope, it's -1. Down 1 and 1 to the right, or you can put as 1 over -1, which means up 1 and 1 left. So in this case, I will go up 1, 1 to the left, and that will be that y-intercept at point 0, comma 2. So B, y-intercept, it's equal right here to. So first I'm creating the equation, then I'm restricting the domain. So function 3 is f of x equal negative 1x plus 2, and only work for x is greater or equal 1. Because like you see, we restrict the domain. I'm sorry, only works for x is greater than 1, not equal. And now we're going to put all together. So the piecewise defined function will be f of x equal. The first function equation was negative 3x minus 6 and works only for x's between negative 3 and negative 2. So I'm talking about this one. This is the equation of function negative 3x minus 6 works only for x's from negative 3 to negative 2. So we have negative 3x minus 6 if x is restricted between negative 3 and negative 2. The second one, the second equation was the constant function y equal 2, and that constant function has restricted domain from negative 2 to 1, including negative 2 and including 1. So that's y equal 2 if x is greater or equal negative 2 but less than equal 1. And the last one, function 3, was negative x plus 2 and only works for x is greater than 1. So we create a piecewise defined function. Okay, so we find the equation of each piece and then we put it together. The last problem of section 3.3, it's about word problem. So let's just read it. Steve Forbes, a presidential candidate in 1996, proposed a flat tax to replace the existing USA income tax system. In his tax proposal, every adult would pay $0 in taxes on the first $13,000 earned. They would then pay a flat tax of 17% on everything over 13,000. Forbes' tax plan is actually a piecewise defined function. So to understand this plan, that means that the resident of USA won't pay taxes for the first 13,000 which they earn, and then for the remaining money which we earn, we have to pay 17% to the government, which means 0.017 of the remaining money which we earn. But we're not paying the taxes, but people won't pay the taxes for the first 13,000 earned. So let's see what they're asking. Here, according to Forbes plan, how much in taxes are owed for someone earning 50,000? So for someone who make 50,000, we know that that person won't pay taxes for first 13,000 which they make. So the person would pay 0% on the first 13,000 and 17% on the remaining On the remaining, which means that person made 50,000, we're not paying taxes for the first 13,000. So for the remaining 37,000, we'll pay 17% tax. So on the remaining 37,000. Okay. So the tax, to calculate that tax, the tax on would be 17%, which is 0.1717%. Change that to the decimal, times 37,000. And this is 6,290. Okay. So that will be the answer. Now, for part B, they asking to find the piecewise function t of x that describe the amount. Okay. So piecewise defined function for this plan will be, so t of x represents here money earned. So x represents dollars earned. Okay, so and t of x represents taxes paid for each money earned. So t of x represents amount of taxes paid. So based on this plan, we know that we pay $0 for the first 13,000. That means for x less than equal 13,000. That will be the first piece. Okay. Now the second piece, for the remaining money which we own, which we earn in a year, we're paying 17% of tax. So that's 17%, which is the same as 0.17 times the remaining money which we made. So technically what we made in a year minus 13,000. So that will be times 17% times, I'll put that in parentheses, x represents dollars earned minus 13,000, because we not going, based on that plan, we're not supposed to pay any taxes for the first 13,000. And this one works only for x's greater than 13,000. So if somebody earn less than 13,000 or 13,000 exactly, will pay zero amount in taxes. If somebody earns more than 13,000, they will pay 17% of the difference between what we earn minus the first 13,000, which is not taxable. In the last part of this example, we have to sketch the piecewise function. Okay, so we have to create a graph. So I'm going to graph the first function in red. So that will be function 1. And I will graph this one in green. That will be function 2 in green. Okay. So let's sketch the graph. Now, y-axis, that's our t of x. Okay, that's how much we're paying in taxes. The x-axis will represent money earned. So that will be 0. So here I will go by maybe by 20,000. This is 40,000. That will be 60,000. 80,000. Okay. So again, x represents at x-axis represents the dollars earned. T of x, amount of taxes paid. So when we talk about amount of taxes paid, let's just go by 2,000. So that will be 2,000. The scale will be by going by 4,000, 6,000, and so on. So first piece of this piecewise defined function saying that we're paying zero money for the first 13,000. So I will put that the 13,000, it's right here. So that will be right here, constant function. For any x from 0 to 13,000, we pay 0 in taxes. That's why you see that constant function. Then the second piece will be the linear function, which means the money which we pay when we earn more than 13,000. So I'm going to use for the first point this information that the person who earns 50,000 pays 6,290 in taxes. So we have that point 6,290. So I'm going to use that information that for 50,000, the taxes which we paid it's 6,290. So 50,000 will be somewhere here. 6,290 somewhere here. Okay. And when a person make 13,000, it will still pay 0. So this is here open. So technically it's going to be a straight line right here, that way. Okay, so this one was that point 50,000, and the taxes on 50,000 at 6,290. Okay. So more money you earn, more taxes you pay, and for the first 13,000, we're not paying anything. Okay. So we have two pieces, constant and the increasing linear function. Okay, so that's it of section 3.3. Hopefully that helps. I'm going to share the videos and the notes on Canvas. Have a great day.